Hello friends, in last video we ended up with a problem. We wanted to find color value of a lost flower. So as a clue we have dataset available. In dataset we have length and width. So we can use it as an input. And we want to find color value, so it will become our output. So we can choose a neural network with 2 input and 1 output. So let's make a neural network with 2 nodes. One is length, another is width, and one node that is color. 2 input, 1 output. In the dataset, length and width are already numeric value. Color is not numeric, it is either pink or green. So let's denote color with a numeric value. Let's denote green with 0 and pink with 1. Now if output value is closer to the 0, then we can assume that it is green. And if it is closer to the 1, then we can assume that output is pink. What we can do on this 2 input so that we can get one numeric output? For that, we need to do some mathematical operation on this. We need to do some algebraic operation and we can get real number. But because we have already assigned 0 and 1 to respective color values, so we need to have output in the scale of 0 and 1. What additionally we can do on this so that we can get output in the scale of 0 and 1? In mathematics, we have a very useful function, that is sigmoid function. Sigmoid of x is equal to 1 upon 1 plus e raised to minus x. This function squash every value between 0 and 1. It doesn't matter whatever you provide to the x. Sigmoid of x will be always between 0 and 1. And if we plot the graph of sigmoid, then it will look like this. In this increasing number line, it will approach to the 1 but never reach to 1. And in the same way, in negative direction, it will approach to the 0 but never reach to 0. It will be always between 0 and 1. Now let's come back to our neural network. This is length, width and color. Let's denote it with M1, M2 and Y. You can see these connections. Those connections are known as weights. And there is one more thing here, that is called bias. These weights and bias are parameters. Let's give name to these parameters W1, W2 and B. Here X is equal to W1 M1 plus W2 M2 plus B. And y is equal to sigmoid of x. Now our complete block diagram is filled. This is our algebraic operation. This is our sigmoid function. These kind of functions are also known as activation functions. And here is our output in the scale of 0 and 1. Now let's see this equation. Here we know y is equal to sigmoid of x. Let's put value of x. W1 M1 plus W2 M2 plus B. Now M1 and M2 are known things which is available in our dataset, because M1 is length and M2 is width. So let's get this value from this dataset. M1 is equal to 2 and M2 is equal to 1 and put this into the equation. Y is equal to sigmoid 2W1 plus W2 plus B. Here we don't know the value of W1, W2 and B. Then how we will calculate the value of Y? You can choose any random value. Let's make it W1 is equal to 0.5, W2 is equal to 0.7 and B is equal to 0. These values are completely random. Now put this value in this equation and it will give final answer 0.84. And if we see in the number line, then 0.84 is closer to the 1. But if we check in the dataset, then it is green, not pink. Then why this neural network has given wrong answer? Because in the beginning, we initialized those parameters randomly. Then how to get correct parameters? For that, we need to check at what proportion output is wrong. And based on the error, we can tune parameter to make it less. Okay, so let's calculate the error. Error is equal to correct value minus predicted value. Correct value is 0 because flower was green and we had denoted it with a 0 value. Predicted value is 0.84. Answer is minus 0.84. We want to get rid of this negative sign, so let's square it. Error square is equal to minus 0.84 square is equal to 0.705. This is error of first reading. We can calculate error from all readings, and if we do sum of that, then it will be known as sum of squared error. This sum of squared error is cost function. This cost function is very important to us because we need to update all parameters in a way that minimize this cost function. And we have a dedicated algorithm for that. That is gradient descent. We will look in detail about this gradient descent in the next video. Thank you for watching.